Hi, welcome to my Unit 5 on strategies to collaborate technology, mathematics, and science. This is Jason Yang, I'll be your presenter. Okay, so the topics that I've chosen to make this integrated unit is exponential relationships in a flu fly colony. It's a lesson sequence that will integrate all three subjects: mathematics, science, and technology. And there's a picture of the proposed fruit fly project that we're going to be working on. Okay, so essential question: what is the connection between exponential function and the population of the fruit fly colony? Okay, so unit questions. So for this whole unit, these are some questions that I'll be addressing. How are exponential functions used in the world that we live in today? How do we know we have exponential growth function? And when we have exponential decay function? And what can we do with exponential functions in the real world? Some of the specific objectives that we'll be working on is write and graph exponential growth functions, write and graph exponential decay functions, explore and understand the fluctuation of population growth in a closed ecosystem, present findings through current technologies by collaborating with classmates, and also explain the significance of fruit fly population model compared to human population model. So these, as you can see, these goals are more specific. They will apply to just one lesson. Okay, so on the standard goals I'll be referring to here are many. I have quite a few from each of the subjects. For math, I'm gonna require students to construct exponential functions and how to describe the relationship in an exponential function by using the input-output pair tables. As you can see, the exponential models will look like this. A leading coefficient times the base number taken to the ct power equals to d. Science standard, it will come from the biological science section, where they will learn stability in an ecosystem is a balance between competing effects. It's very important in this concept. Students will also learn to analyze changes in ecosystem that can result from the changing climates or the introduction of non-native species, change in population size, or it could be limited food resource. In technology stands are many and very important. They will demonstrate fluency in technology system, and they'll also transfer the knowledge they learn into the new technologies. They will collaborate with other classmates, maybe other non-classmates, to present the findings using these new digital tools. Communication is also very important using today's digital technology. Okay, so basically I broke down this whole lesson sequence into a series of 8 different days. Day 1, I will introduce the start of the Flu Fly Colony project. As a one more question, I'm going to have students, think and discuss with a partner on the question, what do you think would happen if fruit flies were to be allowed to reproduce without limits? And is this what happens in nature? Why or why not? What are some other real-life applications to population growth? And students, after the discussion, will start making their fruit fly bottles. We're going to have them break into groups of 3 or 4. In each team's bottle, they will place the fruit fly larvas, fruit fly feeds, water dish, so they all be contained inside this bottle here. And then I'm going to ask them to use tape to enclose top half of the soda bottle like this. And so it will work like a closed ecosystem to note all their observations in their daily logbook. Day 2. Students will have a short discussion of the purpose of the fruit fly colonies to exponential growth and exponential decay. I'm going to introduce the exponential growth curve for human populations. I'll introduce new vocabulary terms relating exponential growth, decay, ecosystem, closed system, and limiting factors. And you can see these vocabulary terms not only relates terms from the science field, but also terms from the math field. Okay. And also, I'm going to have students to observe and record the number of fruit flies in day 2 right now. I'm going to have them log on the logbook and the Microsoft Excel. Day 3. I'm going to give a student a lesson on exponential growth and different examples of exponential growth functions and its graph. I will assign classwork. And some examples will be like these exponential function graphs. See, this y equals to 2 to the x power, y equals to 5 to the x power, and y to the 1/2 to the x power. I have them to graph them using the xy table. And they will share their findings in groups. Again, students will observe and record the number of fruit flies in the bottles in day 3, and they will log it on and record on the Excel as well. Okay, day 4. In day 4, I'm going to have a read out loud on some information towards life cycles of fruit flies. I'm going to have students to discuss and reflect on the reproductive rate of fruit flies. Students will answer the questions. These following questions: how is the reproductive rate of fruit flies similar to the reproductive rate of humans? How is the reproductive rate of fruit flies different to the reproductive rate of humans? And also, I'm going to give the students a lesson on exponential decay and different example exponential decay functions graph. Just kind of like how students have to graph exponential growth on yesterday, they will now graph some examples on decays. And again, they will share the findings in groups. They will all again observe and record number of fruit flies on this day onto the logbook and their in the Excel. Day 5, students will. I'm gonna have students read out about population growth crisis of the human race, and students will discuss and reflect on what's going on with the current human population. Students will answer the following question: what is our current human population? To find that,